We have now worked through all of what we call the fundamental identities. So those are the quotient identities, the reciprocal identities, the Pythagorean identities, and the even-odd identities. Those are the ones you should know. All the other identities that we're going to have are going to be things that you don't need to have memorized, but you're going to be asked to prove them. And we're going to work our way up to that. What I want to do before we prove any identities is just practice doing some of the algebra that we can do as we simplify expressions that involve trig functions. Okay? So here I've got two problems on the board, and we're basically doing the opposite thing with these two problems. So here I say to write this as a single fraction. So right now I have a sum of two terms. I want to combine them into one fraction. I've got a couple of options here. I could, if I wanted to, just write this as a fraction by writing it as secant of x over 1. I can always write something as a fraction by putting it over 1. I think what I prefer to do, though, is to say that that's just the reciprocal of cosine of x. So I'm going to choose to rewrite things this way. And if I want to add fractions, I know that what I need to do is get a common denominator. Now, sine x and cosine x don't have any factors in common, so my least common denominator is just going to be the product of these two denominators. So it'll be sine x times cosine x. So I'm going to multiply this fraction by 1 in the form of cosine x over cosine x. And I'm going to multiply this fraction by 1 in the form of sine x over sine x. Multiplying by 1 doesn't change the value of things, it just changes the way they look. So that becomes cosine of x over cosine x sine x plus sine x over cosine x sine x. And now that I have a common denominator, I can combine this into one fraction, as I was instructed to do. The denominator will be cosine x times sine x, and the numerator is just the sum of these numerators. So it'll be cosine x plus sine x on top. Now, you'll notice the direction said write as a single fraction. They didn't say simplify. That's because simplify would be a little bit vague. I'm not convinced that this is simpler than this. It really depends what I'm trying to do. In some cases, this might be simpler to have. In other cases, this might be simpler to have. So you're not going to encounter directions that say simplify. You'll encounter directions that tell you to change it in a particular way. Okay. Now, if I had written this as secant over 1 instead of 1 over cosine of x, I'd get something that was equivalent to this, but a little bit different. So there are often more than one correct answer. As you're doing the homework, if you think you've done things correctly and your answer doesn't match the back of the book, just shoot me an email or come into office hours and I can let you know whether your answer is an equivalent version. You might be able to check it, but if you're not sure, feel free to ask. Okay, so here we were taking two pieces and we were combining them into one fraction. Now here we're going to do exactly the opposite. Distribute the division. On top I have an addition problem. We're dividing the whole thing by cosine of x. But division, just like multiplication, distributes over addition and subtraction. So I could say this is sine x over cosine x plus cosine x over cosine x. And then I can simplify each fraction. I could say that's tangent of x plus 1. Cosine over cosine is going to be 1, at least provided that cosine isn't 0. Okay. And of course, if cosine was 0, tangent wouldn't be defined. So we're good to go. Okay. Notice distributing the division is essentially like undoing the addition of two fractions. Here, if I were to distribute the division of cosine x times sine x, it would take me right back to this version of things. I would have two separate things being added together. We found a common denominator to write as one fraction. Here, we distributed that common denominator, and we got something that had two terms in it.